All right, so let's apply this into an example now. So we're going to write the predominant reaction when drain cleaner is combined with hydrocyanic acid. I'm going to add the word solution here. Okay, can't quite fit it all in there. So what we got to do, just like when we were doing redox, is get all the entities present. So it's usually much simpler with an acid base. So we got sodium hydroxide in a solution that's going to dissociate. So we're going to have sodium ions, hydroxide ions, which will definitely be the strongest base. Hydrocyanic acid, it's a weak acid. Maybe you don't have the strong acids memorized, but you got a data table. Okay, I'm going to be using this table of acids and bases now. Okay, the 6 strong ones are at the top. I don't see HCN anywhere. Ooh, I do see like a coffee stain. That's interesting. Okay, moving down the list. Do I see it? HCN? Yeah, it's there. Okay, it's a weak acid. So you just write it HCN. Okay, there's a solution involved, so we should write H2O. You will run into questions where H2O is going to act as the acid or the base. Okay, now just like with redox, let's find our strongest acid and our strongest base. Okay, the acid-base table works just like the redox table. The strongest acids are at the top and they get weaker as you go down. The strongest base is at the bottom and they get weaker as you go up. Check it out. OH is the strongest base, so it's definitely going to be our strongest base. It has to be. Let's find our strongest acid. Okay, we don't have too much to consider. HCN is not a very strong acid, but here it is. It's above water. Water can be your acid, but HCN is a stronger acid than water because it's above it in the table. So that's going to be our strongest acid. Okay, you won't find sodium anywhere in the acid-base table. All right, so we got our strongest acid and our strongest base. We know how to write an acid-base reaction. Okay, start with the strongest acid and the strongest base. The acid gives a proton to the base. That's it. So we're going to get the Cn minus ion, cyanide, and water. All right, the last thing you got to do, and it's so similar to redox, is you can determine generally what the yield of the reaction is. Okay? If the strongest acid is above the strongest base, you get a greater than 50% reaction yield. Okay? So I'll write that down. If SA is above the strong base in the acid base table, okay, the yield is greater than 50%. Okay, if it's below, the yield is less than 50%. Also, I don't know if this will ever come up. Okay, but that's a product's favored reaction. So Kc is going to be greater than 1. Remember the equilibrium constant? Heads up, it's coming back in a big way. Stay tuned.